Questions are relatively tough today. A stone is dropped from a tower 72 meter. No, a stone dropped from a tower covers 72 meter in last 1 second of the journey. How much distance it covers in middle 1 second of its journey? करके बता सकते हो क्या? How much distance it covers in middle 1 second of the journey if it covers 72 meter in the last 1 second of the journey? Try this. 2 minutes. You can take G is equal to 10 meter per second square. You can take G as 10 meter per second square. Okay, so it covers 72 meter in last 1 second. So 72 is equal to half into A into 2n minus 1, right? So 2n minus 1 is 72 by 5. So n is equal to 7.7 seconds. Okay. So this is the total time. So how much, what is the height of the tower? Then the height of the tower is h is equal to half a t square. Then what is the average velocity over the entire motion? Total height upon total time, which will be half into 10 into 7.7, which is 77 by 2. 38.5 meter per second. Now I'm going to give you a very interesting result. If the particle is uniformly accelerated, then the distance traveled in the middle time is exactly V average into middle time. In the middle. So if the average velocity is 38.5, then in middle 1 second, it will travel the distance d is equal to V average into 1. That will be 38.5 meter. A new concept, I think, for every one of you, right? If the particle is telling me the constant acceleration, then if you know the average velocity of the entire time period, then in the middle of the journey, the distance travel will be average velocity multiplied by the duration of the middle. Here it's saying in the middle 1 second. So in the middle 1 second, it will travel the distance V average multiplied by 1. Is this clear?
Yes, sir.
Yes,
Arna. Middle of the journey. Clear?
yes.
New concept for everyone, I think so. Okay, next question. A particle covers first half of the distance with a uniform velocity v, and the second half of the distance with uniform acceleration along a straight line. If in the entire journey the maximum and the minimum velocities are 2v and v, find its average velocity. None of the question is lengthy, remember. Every question is tricky. You can always solve it very fast. No? Okay, let me solve it. Let's say this is the total distance s. Half the journey it travels with a uniform velocity v. In the remaining hour, this is uniform acceleration. Uniform acceleration. And it says in the entire journey, the maximum and the minimum velocities are v and 2v and v. That means here it's v, here it's 2v. Okay. We know that for a particle moving with uniform acceleration with initial velocity u and final velocity v, the average velocity is given as u plus v by 2. So for this motion, the average velocity will be v plus 2v by 2, that is 1.5v. Now we come back to the original problem we did. Half the distance with the velocity v and half the distance with the velocity 1.5v. If it's half the distance, or if it's equal distance, then your average is what?
Sir, harmonic mean.
Harmonic mean. So the average for this will be twice of v1, v2 divided by v1 plus v2, which will be 3v divided by 2.5. Am I right? 3 divided by 2.5. Okay. So 1.2v. So this is the answer. Is this clear to everyone?
Yes, sir.
Yes, sir.
Arna,
Yes, sir.
is this new to you? In fact, to everyone. This is a simple concept, right? This average velocity of harmonic mean, we did it. We all know that when if it's uniform acceleration, the average velocity is initial velocity plus final velocity divided by 2. And for this uniformly accelerated motion, we just find out the average velocity for this, and then we did the question. Okay. Next question. No, we'll do this question afterward. Let me take the next question. How are you trying it? Any approach? Arna? Suhail?
Sir, we can use the equation S is equal to UT plus half AT square.
Oh, that is very complicated. Sanvi? Okay, you know the result. If the particle is the distance traveled by the particle in the nth second is u plus half a 2n minus 1. And you also know that if u is equal to 0, then the distance traveled in first second, second second, third second is given in the ratio of 1:3:5:7:9, right? Whatever. What is this? This is the ratio of the distance traveled in the subsequent seconds. Subsequent seconds. First second, second second, third second, fourth second. Provided u is 0. Here also the particle is dropped. What I am saying is, I can generalize this result. What is the general result? A particle is starting from rest and moving with constant acceleration. Same. A particle is starting from rest and moving with constant acceleration in successive equal interval of time. What I'm saying? In successive equal interval of time, it covers distance in the ratio 1:3:5:7:9. Okay, I have modified, or if I have generalized this result, this ratio was given for first second, second second, third second. So the interval is of 1 second. Now I'm saying you take any interval, whether it's 1 second or 1.5 second or 2 second, then in successive equal interval of time. So I can take the interval here as 1.0 to 1.5, 1.5 to 3, 3 to 4.5, 4.5 to 6, 6 to 7.5, and like this. So distance will be in the ratio of 1:3:5:7:9. So this is what? 1.5 to 3 seconds. So this is in the second interval. Okay. And this is 4.5 to 7. So this is first interval, second interval, third interval. This is fourth interval, and this is fifth interval. So it's asking distance in this second. So the distance in these two intervals will be in the ratio of 3:7 plus 9. So the distance traveled in this interval is, let's say, S. And the distance traveled in this interval is 3.6. So S upon 3.6 is equal to 16 upon 3, right? 16 upon 3. So S is equal to 16 into 3.6 divided by 3. 16 into 1.2. 19.2 meters. So the answer is 19.2 meters. Is this clear?
Yes, sir.
Yes, sir.
So,
Yes, sir.
are you able to grasp it? What I have done? If a particle starts from rest and is moving with a constant acceleration, then in successive equal interval of time. Now, I'm not saying first second, second second, third second. I'm saying in successive equal interval of times, it covers distance in the ratio of 1:3:5:7:9. You can check it. Distance travel in the first interval will be half a 2t1 minus 1. Okay. Now, distance travel in the second interval will be s2 minus s1, which will be half a twice of t1 square minus half a twice of t1 minus 1. And you can simplify this and you will get the ratio is 1:3. The same thing we did now for the to find out this. What we did was distance travel in 1 second, distance travel in 2 seconds. Then the distance travel in the second was what? Distance travel in 2 seconds minus distance travel in 1 second. The distance travel in third second was distance travel in 3 seconds minus distance travel in 2 seconds. And that is how we find the ratio. So now instead of taking first 1 second, 2 seconds, you take time interval t1, then time 2t1, then time 3t1. So it will be, ratio will be first interval is t1, second t1 interval, third t1 interval, right? Like this. Is it clear or should I solve it for you guys?
Sir, it's clear.
It's
So
clear?
clear.
Okay, fine. Next question. Particle is moving with uniform acceleration along a straight line. First thing is, it's moving with uniform acceleration along a straight line. Time versus displacement graph is as shown in the figure. Okay. Tangent to the curve at the point P. This is the point P for this tangent. The curve. The tangent to the curve at the point P makes an angle of 60 degree with the x-axis. Line OP makes an angle of 30 degree with the x-axis. If the tangent drawn to the curve at the origin, so we are drawing the tangent to the curve at the origin like this here. Okay, somewhat like this. Makes an angle theta. So this angle will be theta. With the x-axis, then tan theta is equal to. So what we are given? We are given a displacement time graph. There is a point P on the displacement time graph. Then the tangent to that curve makes an angle of 60 degree with the x-axis. And the line joining O to P makes an angle of 30 degree with the x-axis. It's saying that what is the tan theta of the line which is tangent to this curve at the origin. I will give you guys 3-4 minutes. You can try this question. ओके, मैं करूं क्या? You need some more time.
Sir, 1 minute.
Arna, Sanvi, are you able to solve it? Are you getting any direction how to solve it? No? Okay. See here. First thing, this is moving with uniform acceleration along a straight line. So all our results, V will U plus AT, S will UT plus half AT square, they are all valid here. But this is not displacement versus time. This is time versus displacement. So this line which is tangent at the point P, the slope gives us dt by dx is equal to 1060. What is 1060? Root 3. And this gives us dx by dt is equal to 1 by root 3. And dx by dt is what? This is v. So we get v at that point. Now it's asking the slope of the line at the origin. That means it's asking us what is u, initial velocity. No, it's not asking u. It's basically asking dt by dx at t is equal to 0. So it's asking us 1 by u. So it's asking us what is 1 by u equal to. Okay. So now again, what is given here is in this graph, if you see here, the slope of the line OP is given. So 1030 is basically what? If I see a 1030 is t by x. This is equal to t by x. So what is x equal to? X is equal to 1030 is root 3. No, 1 by root 3.
Sir, 1 by root.
So x is root 3 times t. X is root 3 times t. And that is equal to ut plus half at square. So what we get is root 3 is equal to u plus half at. Now how to get rid of this at? Any idea? How to get rid of this at? Any idea? Because acceleration is not given. Okay. 2 root 3 is equal to 2u plus at, which is equal to u plus at. And what is u plus at? That is v. And we have that. So what we get is 2 root 3 is u plus 1 by root 3. So what is u? U is equal to 2 root 3 minus 1 by root 3. So this will be 5 by root 3. So what is dt by dx at t is equal to 0 is 1 by dx by dt at t is equal to 0, and dx by dt at t is equal to 0 means u. So this is 1 by u. So this is equal to root 3 by 5. So this is the answer, root 3 by 5. It was involving some concept of slope of the line. But we know that because we don't have to differentiate anything, we know slope of the line is always tan theta. So dy by dx, we are not doing any differentiation. We are just using the term dy by dx is tan theta. Any doubt in this question?
No, sir.
No, sir.
No, sir.
Was this question difficult for you guys?
Yes, sir.
Yes, sir.
But yesterday's session I think was very easy. So I thought let's bring some difficult question, because if the questions are too easy for the student, then the students will not enjoy the class. So there has to be some learning. So these questions are really good questions. One of the, like, my good collection questions. Like, I give this to very students who are like preparing for IIT and doing very good actually. So next, move to the next question. A particle is moving in a straight line with uniform acceleration. During a certain interval of time of 8 seconds, its average velocity is 12 meters per second. In first 3 seconds and 20 meters per second for last 1 second. What is the average velocity for middle 1 second? First, try to read this question carefully and get the language part of it, what the language part of it is. And then try to draw the conclusion, what is physics in it, and then solve this question.